Hi students, today we are going to study the properties of discrete convolution. Okay, so let's see the properties. The first property is distributive property. Okay, so the distributive property says that, okay, so this is all about some notations, changes in notation and brackets. Okay, so distributive property says that x of n convolution h1 of n plus h2 of n will be equal to x of n convolution h1 of n plus x of n convolution h2 of n. So where in case of an LTE system, x of n is the discrete LTE system, x of n is the input or excitation to the system, and h of n, it can be either h1 of n, h2, anything. When h of n comes, it is the impulse response of that particular LTE system, and y of n will be the response. Total system response will be represented by y of n. Till we discussed about functions in terms of t, that is continuous time. So here we are describing about discrete convolution. So the variable will be n. Okay. So here it shows that equivalent system for the distributive property. Here it shows we are having two systems, system 1 and system 2. The system 1 say LT impulse response is h1 of n, and system 2's impulse response is h2 of n. And when we are giving the same input x of n to the both systems, first system will produce a response y1 of n, second system will produce an output y2 of n, then we are adding that together to produce the total response y of n, that is x of n. When a system is given with an input x of n, it will produce an output y of n. Okay, so this totals the figure or the circuit or the connection diagram in E can be uh, redraw like this, that is the two systems response are combined together like h1 of n plus h2 of n, because here we are adding. Okay, so the total system response will be rewritten as h1 of n plus h2 of n, and we are giving x of n input to that system, and it will produce an output y of n. Okay, so here we are having the proof for that. So from this figure A and B, we know that y1 of n will be x of n convolution h1 of n, and the y2 of n will be x of n convolution h2 of n. Then the total output is y of n is equal to y1 of n plus y2 of n. Then we know that what is y1 of n and y2 of n. So we found it is here. Okay. So we are writing the values of y1 of n and y2 of n here. So we know the convolution equation, discrete convolution equation, and we rewrite the equation like this. K is the convolution variable. Okay. So the summation and the x of k term is common for both, and we are taking common that summation k is equal to minus infinity to infinity. X of k is taking outside, and the rest of the terms is like this: h1 n minus k plus h2 of n minus k. So these two together we can write h of n minus k. So this would be equivalent to x of n convolution h of n, where h of n is equal to h1 of n plus h2 of n. Okay, so when two systems are connected in parallel, it should satisfy distributive property. And the second property is associative property. Okay, so here it is all about this square bracket. Okay, when we are convoluting x of n and h1 of n, then the resultant of that convolution is convoluted with h2 of n will be equivalent to convoluting x of n with the convolution result of h1 of n and H2 of n. Okay, so here we are using a cascaded system. Okay. So let's see. So we are having one system which is having impulse response h1 of n, and we are giving input x of n to h1 of n, and it will produce an output y1 of n, and that output y1 of n is given to another system with impulse response H2 open, and this will produce an output Y open. Okay, so these cascaded systems can be rewrite as x1 of n convolution h2 of n. Then we are giving our input x of n here and it will produce an output y of n. Okay. So let y1 of n be the output of the first system. So what is the equation for y1 of n? Y1 of n will be equivalent to x of n convolution h1 of n, and we are writing the convolution equation expansion. Okay, so what about the second system? The output of the second system is y of n, and the input is y1 of n convolution h2 of n. Y1 input is y1 of n, and the total system response is y of n is equal to y1 of n convolution by h2 of n. So we know what is y1 of n, and we are writing that here, and we are applying that convolution. We are uh, expanding this convolution, and we are taking k minus vs. We need to use two convolution variables. First case, in case of y1 of n, convolution variable is k, and in case of y of n, convolution variable is p. So it comes a term like k minus p. So we are rewriting that by l, and on rearranging we will get y of n is equal to x of n convolution h of n, and where h of n is h1 of n convolution h2 of n, like that. Okay, so this is all about associative property, and the third property is commutative property. So commutative property, we know that a plus b is equal to b plus a, like that. So here h1 of n convolution h2 of n would be equivalent to h2 of n convolution h1 of n. Okay, so we are having the proof. Here it is the expansion for h1 of n convolution h2 of n. It would be appear like that, and we are rewriting n minus k by p. So then what is p? P is, what is k? It is n minus p. So like that, it will like this. Then we will get h2 of n convolution h1 of n. So commutative property is proven. Okay. So the next property is shifting property. So shifting property is that we know the convolution x of n convolution h of n will give an output y of n, and we are giving a shift of k to the input and the impulse response of the system. So let's see what happens in the total system response. So we are convoluting x of n minus k and h of n minus n. The total system response will get a shift of n minus k minus m. So this is all about shifting property. Next is the convolution with impulse. So impulse is basically if signal is having value 1 at t is equal to 0. Okay, so we are basically considering that it's a UAG. Okay, so it is similar to multiplying that system on signal by 1. Okay, so here it is x of n convolution delta of n, it will give an output x of n. Same, whatever be the input, it will give that input at the outside. Okay. So convolution with shifted impulse. So we have found what happens when a signal is convoluted with impulse. Now we are convoluting with the shifted impulse. Okay. So shifted impulse means delta of n minus n zero. So that shifting is appears at the output also. X of n will be shifted to x of n minus n zero. So this is all about the properties of convolution.